Okay, let's work on number 26 here together. In the xy plane, the parabola has a vertex 9, negative 14. So I'm gonna make a rough sketch. In the xy plane, x equals 9, y equals negative 14 up there. Intersects the x-axis twice. So 2 points. It's gonna have a U shape facing upwards, which tells us that a has to be greater than 0. And this point here is 9, negative 14. And intersects the x-axis at 2 points. And if the equation of the parabola is written in the form y equals ax squared plus bx plus c, where a, b, and c are constant, which of the following could be the value of a plus b plus c. The ultimate goal is to find the sum of all these coefficients in the quadratic function. Okay, so we're gonna first write in the vertex form because they gave us the vertex. The vertex form is a complete square form where y equals a x minus h squared plus k. So we can say that h equals 9 and k equals negative 14. So I'm going to plug it in. X minus 9 squared and k will be negative 14. But plus and minus here, we can just simplify it as just 1 minus 14. Just minus 14. Alright, so we got the y equals this quadratic form. Okay, so to write this in standard form, we're gonna have to FOIL it. So y equals a x squared minus 18x plus 81 minus 14, and then you're gonna distribute all this. Okay, so we can compare it with the standard form as a equals a, b is equal to the coefficient of, oh, not that one. Okay, just the coefficient of negative 18a. And then we can say c equals all this constant. Anything that's not dealing with the variable x will be grouped together. So here we have a equals just a. Okay, so why don't we do this? We're gonna say, we're gonna first add all these together. So a, negative 18a, and let's add them up. So what do we have here? A minus 18a plus 18a, 81a minus 14. Combine all these three terms, you're gonna get 60. Okay, these add up to negative 17 minus 81 minus that, you get 64a minus 14. So when we get this far, okay, all these sum can be, okay, because all these are representing a, b, and c. These can't, okay, if you go with choice A, let's say this equals negative 23, but we know that A has to be greater than 0 because remember in the beginning we said we have a 2x intercept, so A has to be positive. So if you add 14 on both sides, but we get in trouble. Our A value is negative, so this cannot work. So we try 64a minus 14 is equal to negative 19. So add 14 on both sides. And again, we run in trouble not getting value a being positive. It's still negative. A has to be over 1. Or A has to be positive, my bad. A has to be positive so that it's facing up and can cross the x-axis. So B doesn't work. C, negative 14. Okay, negative 14 seems like okay, but after you cancel that, it says a equals 0. But if a equals 0, it's not quadratic. It's a linear function, as you can see here. When you have ax squared, that will be 0 plus bx. That's a linear function, and that's not what we want here. So the answer is D. When you have negative 12 for the sum of these coefficients of quadratics, in terms of a, we add 14 on both sides, and now we have positive value 2 equals 64a, and a is 2 over 64, and that's greater than 0. Therefore, it will face up and satisfy our condition.